Imagine waking up one morning to discover that a single scientific experiment conducted by a handful of brilliant minds came closer than anyone expected to erasing an entire city from the map, not through malice, but through uncertainty, calculation limits, and the terrifying gap between theory and reality. This is not a story about madness or recklessness, but about intelligence pushed to its absolute edge, where equations meet fear, where the human brain becomes a live testing ground for uncertainty itself, and where one experiment forced humanity to confront how little it truly understands about the systems it tries to control. In July 1945, deep in the New Mexico desert, scientists prepared to conduct what was known as the Trinity Test, the first detonation of a nuclear weapon, an experiment designed to validate equations written on chalkboards and tested only in the abstract realm of mathematics. Yet what very few people know is that this experiment carried a non-zero probability of catastrophic failure so large that it could have incinerated nearby towns, poisoned ecosystems, and fundamentally altered human history in a single uncontrolled moment. At the center of the story is not just physics, but neuroscience, psychology, biology, and the way the human mind behaves under extreme uncertainty. Because when you examine this experiment closely, you are not just observing a technological milestone. You are watching the human brain negotiate fear, confidence, and survival at the same time. The scientists involved were not ignorant of the risks. They were acutely aware of them, and this awareness activated deep neural circuits related to threat perception, decision-making under stress, and the limits of rational thought. The brain, when facing uncertainty, behaves like a predictive engine, constantly running simulations, estimating probabilities, minimizing surprise. And yet when the system itself is unprecedented, when there is no prior data, no evolutionary memory to rely on, the brain must improvise. This is where the Trinity Test becomes more than a historical event. It becomes a case study in cognitive limits. The human brain evolved to handle lions, droughts, and rival tribes, not chain reactions that could theoretically ignite the atmosphere. And yet, this was a real concern at the time. Some physicists openly debated whether the nuclear explosion could trigger a runaway fusion reaction in the nitrogen of the atmosphere, effectively setting the sky on fire. Calculations suggested it was unlikely, but not impossible. That word, not impossible, is where neuroscience enters the conversation. The brain does not treat low probability and zero probability the same way. Under stress, the amygdala amplifies uncertainty, while the prefrontal cortex attempts to suppress emotional noise and focus on logic. This internal conflict was present in every scientist standing at the test site. They were systems under load. Humans are energy networks, and stress is not just emotional, it is metabolic. Cortisol levels rise, attention narrows, perception distorts, and time itself feels different. Some witnesses described the minutes before detonation as surreal, as if reality had slowed down. This is a known neurological effect. When the brain anticipates extreme outcomes, it increases sensory sampling, effectively recording more data per second, creating the illusion of slowed time. The experiment was not just testing a bomb, it was testing the human nervous system. When the countdown began, the desert was silent, and yet inside the minds of those present, millions of neural signals were firing, predictions clashing, simulations colliding. Thought is a signal, and in that moment, the signal-to-noise ratio was immense. The brain's default mode network, usually active during introspection, was likely suppressed, while task-positive networks dominated, focusing entirely on the outcome. This is how humans survive dangerous environments. But survival mechanisms can also blind us. The same neural circuits that allow us to act decisively can suppress doubt, even when doubt is warranted. This is one of the most unsettling aspects of the story. The scientists had calculated the risks, they had debated them, but ultimately, they proceeded. Why? From a psychological perspective, this is a phenomenon known as commitment escalation. Once significant cognitive, emotional, and social resources are invested in a project, the brain becomes biased toward continuation. Stopping feels more dangerous than proceeding, even when the unknown looms larger ahead. The human brain is a system that seeks coherence. Unfinished narratives generate discomfort. The Trinity Test was the culmination of years of work, and the idea of not knowing became more intolerable than the risk itself. This is not a flaw unique to scientists, it is a fundamental feature of human cognition. We are pattern-completing organisms, and yet biology adds another layer. The body under prolonged stress adapts. Neuroplasticity reshapes circuits based on repeated exposure. Scientists working on the Manhattan Project lived for years under secrecy, pressure, and moral ambiguity. Their brains adapted to this environment. What might have felt unthinkable at the beginning became normalized. This is how extreme situations become psychologically survivable. But normalization does not equal safety. On the morning of the test, weather conditions were unstable. Wind patterns could have carried radioactive fallout toward populated areas, including nearby towns. If the explosion had been larger than expected, or if containment had failed, the consequences would have been catastrophic. A whole city could have been rendered uninhabitable, not by intention but by miscalculation. This is where the concept of limits becomes crucial. Physics has limits, biology has limits, and cognition has limits. The equations used were correct within known parameters, but unknown variables always exist. In neuroscience, this is analogous to perception. The brain constructs reality based on incomplete data. It fills gaps, assumes continuity, predicts stability. Most of the time this works. Sometimes it fails spectacularly. The Trinity test was humanity betting that its models were good enough. When the bomb detonated, the light was brighter than the sun, visible hundreds of miles away. Some observers reported seeing their bones through their hands. This is not poetic exaggeration, it is physics. The sudden burst of gamma radiation temporarily overwhelmed the visual system. The retina, flooded with photons, transmitted a signal so intense that the brain struggled to process it. This moment illustrates how fragile perception really is. Our senses evolved for a narrow range of inputs. Beyond that range, the system breaks down. The shockwave followed, a physical manifestation of energy release that the human body could feel before the mind could fully comprehend. For a brief moment, silence returned, and then came the sound, delayed by distance, a reminder that cause and effect are not always simultaneous. This delay is also present in the brain. Emotional reactions often lag behind sensory input. Only after the explosion did the full psychological weight settle in. Relief, awe, fear, guilt, pride, all competing within the same neural space. The experiment succeeded, but success is a dangerous word. Because success here meant proving that a theoretical framework could produce unprecedented destruction. From a systems perspective, this was a phase transition. Humanity crossed a threshold. The energy density unlocked was orders of magnitude beyond anything previously controlled. And once a system crosses such a threshold, it cannot return to its prior state. The city was spared, but the world was changed. The twist in this story is not that humans nearly destroyed a city, it is that the very mechanisms we interpret as weakness, fear, hesitation, doubt, are actually protective features of the brain. When a scientist felt anxious before the test, that was not failure. That was the brain's threat detection system functioning correctly. Anxiety is a signal, not an error. Doubt is not paralysis, it is feedback. In neuroscience, the brain constantly balances exploration and exploitation. Too much exploration leads to chaos. Too much exploitation leads to stagnation. The Trinity test pushed exploitation to its extreme, and the discomfort felt by many involved was the brain signaling that the system was operating near its limits. Modern culture often glorifies fearlessness, but biology tells a different story. Fear is an adaptive response. It sharpens perception, increases learning, and forces caution. The tragedy is that in large systems, individual fear can be overridden by collective momentum. This is a lesson that extends far beyond nuclear physics. In psychology, we see similar patterns in financial bubbles, technological overreach, and even social movements. When enough minds align toward a goal, dissenting signals are dampened. The system becomes efficient but brittle. The Trinity test did not destroy a city, but it revealed how close human systems can come to irreversible outcomes without fully understanding them. It showed that intelligence alone is not enough. Wisdom requires respecting limits, including the limits of our own cognition. Today, as we experiment with artificial intelligence, genetic engineering, and planetary-scale technologies, the same neural dynamics are at play. The brain still seeks completion, still normalizes risk, still underestimates low-probability, high-impact events. The lesson is not to stop experimenting, but to listen more carefully to the signals our minds produce under stress. That uneasy feeling, that pause, that question of what if is not weakness. It is the brain protecting the system. The experiment that nearly destroyed a whole city did not fail because it revealed danger. It succeeded in revealing something far more important, that the greatest risk is not in our machines but in our assumptions about control. Science advances by pushing boundaries, but survival depends on knowing where boundaries exist. As you reflect on this story, ask yourself this: in a world where knowledge grows faster than wisdom, how do we ensure that our experiments test reality without testing the limits of existence itself? If this made you think differently about science, the brain, and the hidden costs of progress, write your thoughts in the comments, like the video, and subscribe to MindSpark Science for more deep, science-driven explorations that challenge how you see the world.